Hi everyone. Welcome back to the session on Reliance aids, the reliability aids. The reliance of word is not confined to any industry. Reliance is the reliability that the customer can have on a particular system. So different reliability aids are there, as we were discussing, and then we have understood that the information technology, usage of the information technology to gather the data, to process the data, the enterprise will be more dynamic when it is integrated, and then when it integrates the data with the creative ideas, it can evolve with the different modules, and it can definitely give out the models in an effective way. For the effective use of the information technology, IT usages, we have the open source software, and we have got the particular hardware, and we have got the data analytics, we have got the artificial intelligence, we have got the deep learning these days, and the machine learning and the deep learning are going to be very much involved in it. And information technology has got revolutionary changes has brought into it, and then the simulation software packages will definitely give us the idea that where the data could be processed in a better way, and it could be modeled into the new configurations. That is for the effective use of information technology. We need to have certain questions. Does IT connects to the various activities of the whole organization? And the second question that comes is that, is the information system centrally managed by the enterprise and it is compatible throughout, and the whole team that is going to work on the IT data, is there a transparency between them, and is it an information network centrally, it is accessible to everyone, and does it capture relevant and the useful information? Does it helps in converting the informations into the fact-based decisions? Does information system allows to understand the consumer very well? SCADA systems are in place, and then every minute information, every second information is gathered, and it allows the central units to understand that which distribution system is performing in a better way, which is giving the power in a quality way, and which is going to give the power at the time of need, and how well they are maintaining their demands. All these are centrally accessible, and it is accessible to everyone. So the enterprise will be very dynamic. Next, coming to the second one, which is going to give the reliability aid, is a system configuration. System configurations plays a major role in terms of reliability. For system continuity, considering the long outages and then the momentary interruptions, the better system reliability is rated are in the following order of merits. So if we can rate this system better system reliabilities in terms of the following order of merit, we must understand that the first one will be the grid network, second one will be the spot network, third one will be secondary selective, the fourth one will be primary selective, and followed by primary loop, and then the radial one. For the system continuity, all these are going to play a major role in terms of outages and then the momentary interruptions, because the entire continuity depends on all these which are involved in the distribution systems. So coming on to the third category, third one, which is going to be the standardization. We can think that standardization definitely requires the data. It is necessary to evolve with the planning, designing, operation and maintenance, material that is manufactured, that is used for the manufacturing, constructional and then the institutional standards, codes that are involved in it, the flow charts, the algorithms in respect of the following, with respect to the regular reviews and then the updations, definitely involves the standardization of the equipments. So standardization is not only for the equipments, but also involves a different kind of the systems that are in place. First one that we need to consider towards the standardization is that specification for the equipment of mass utilization. Distribution transformers are into the mass utilization, cables are into the mass utilization, protective equipments are into the mass utilization. So all these are going to be need to be specified and in a standardized way. Second one is the constructional standards for the installation towards the various equipment connections. ISO standards are in place, and then the other standards which are relevant to the codes We were speaking about the standardization, and then the standardization is not only for the equipment. It definitely involves the constructional standards for the installing various type of equipment connections too. So see, for example, there are 11 kV lines. When we consider the distribution system, when we consider the primary transmission system, secondary transmission system, primary distribution system, and the secondary distribution system, we have understood that the generated voltage is stepped up, and then that definitely involves the transformers. And the different type of materials for the transmission lines, and again it is stepped down with the help of the step down transformers. There are distributors, there are service mains, and these kind of the arrangement definitely requires the constructional standards. Tapping arrangement for the 11 kV line has to be standardized, and then the sagging arrangement, the type of the sag that can happen, and then what is the customer protection, fuse arrangements that has to be taken care of, because the protection is very, very important. So manuals for the guidance of the field staff. Suppose think that there is a hotline maintenance, and then the hotline repair that has to happen, wherein the live wire has to be repaired. So there should be a manual for the guidance of the field staff, and there should be software packages for the different computer studies that should be standardized, and the softwares that are to be used has to be standardized, license version packages to be in place, and training institutes need to be well established with respect to the technology, and then the training that is to be provided to all kind of staff, including the line staff, and then the maintenance engineers, everyone. And the power quality, next most important topic for the discussion is the power quality. Power quality refers to the maintenance of the voltage and the frequency on a power line. So the less voltage waveform distortion, maintaining the voltage levels and the frequency levels within the tolerable limits, and the voltage having the less harmonics, and then the balancing of the loads, maintenance of the rated voltage and frequency, it determines the total power quality that is supplied. The most common types of power quality problems that are associated with the power transmission and distributions are: first one is the drop in the voltage level, that is voltage dip, voltage swell, harmonic distortion, voltage fluctuations, noise levels, and voltage unbalance. Let's discuss one by one. Drop in voltage is also called as the voltage dip. Normally, voltage dip is defined as a decrease in the voltage level between 10% to 90% of the normal voltage, 10 to 90% of the normal voltage at power frequency. Power frequency, we know that in India it is 50 Hertz. In other countries it is 60 Hertz. So if there is a decrease in the voltage level between 10% to 90% of the normal voltage at power frequency, it can be called as the voltage dip or voltage sag. This voltage sag is nothing but the sudden voltage dip, and this may happen due to the sudden switching of loads, or it may happen due to the sudden switching of large motors. It may happen due to the sudden switching of fast switching devices. It may happen due to any fault in the transmission and distribution network. Next one is the voltage swell. Swell itself says that there is a swell of anything that is beyond the proportions. It is a momentary increase of the voltage which is outside the normal conditions of tolerances, which exists more than a cycle, or it can be typically more than few seconds. It is called as voltage swell. It is due to the start and stop of the loads intermittently, or it could be the sudden start. Harmonic is one of the major important factor which should be considered, because we know that in the traction services there are adjacent lines like power lines, and then the communication lines will go parallelly, and harmonic distortion is one of the major area of the research which determines the third harmonic and then the fifth harmonic, which are going to be dangerous to the signal equipments as well as the power line carriers. Due to the presence of the harmonics, current and the voltage waveforms are having non-sinusoidal shape. So beyond the sinusoidal shape, if there is anything, then it leads to the losses. These waveforms are the sum of different sine waves with a different magnitude and then the phase, which are having the frequencies in the multiples of the power frequency. The main causes of the harmonics are the fast switching devices like MOSFETs, IGB, It could be the SCRs or the arc furnaces or the welding machines or heavy industries like textiles. And it could be using the nonlinear loads, or it could be using the rectifiers as in the DC substations. It could be due to anything. I mean, any of these problems, the harmonic distortion reflects in the power quality. So the harmonic distortion reduces the efficiency of the electrical machines because the sinusoidal waveform will be distorted, and overheating of it results in the overheating of the cables and then the equipments. And it is a serious problem which should be arrested in the beginning itself, or in the base itself. So the fourth type of the problem that decides about the power quality is voltage fluctuations. What are voltage fluctuations? Voltage fluctuations are the fluctuations of the voltages beyond the tolerance level. Oscillations of the voltage value and its amplitude is termed as the voltage fluctuations. The frequent start and stop of the electrical machines could be induction motors, or it could be starters. This may cause the voltage fluctuations due to the non-linear loads, or it could be due to the heavy demand that might arise all of a sudden in any one particular area, that might result in the voltage fluctuations too. And due to the nonlinear loads, chokes and the voltage fluctuations may appear, and it could be the inductive load that might draw more current and then it might distort, and the voltage fluctuation may appear and reflects in the flickering of the lights. We might observe that there could be flickering of the tube lights because of the voltage fluctuation that might happen. All of a sudden, there could the voltage levels may dip. This problem is normally observed during the summer season. So the next type of the power quality deciding factor is the noise. Superimposing of the high frequency signals on the waveform of the power frequency is noise. That is, some of the causes of this noise are microwaves, welding machines, arc furnaces, improper grounding, etc. And it can vary the signal levels. It can create the crosstalks in the telephone lines if it is a landline, and data processing errors may happen, data losses could happen. IT industries would definitely suffer, and then the broadband will also suffer if it is a cable line. And the noise is the major disturbing factor in the telephonic lines, and it could happen it could definitely affect the LAN networks. And voltage unbalance is another factor which decides the power quality. In a three-phase systems in which magnitude and then the phase angle between them are equal, normally it is 120 degree apart, and if the phases are going to have a different phase angle between the three phases R, Y and B, it reflects in the unbalance of the voltage. This error may cause due to the unbalanced loads again, and it may be created due to the faults that might have occurred on any one of the phase, due to the fault that might be a remote fault that might have occurred in any of the remote phases before entering into the secondary distribution. Also due to the voltage unbalance, negative sequence current exists. There are three types of sequences, that is the positive sequence, negative sequence and then the zero sequence. And the negative sequence of the current is very harmful, and it definitely reflects on all the three-phase loads, and it is going to damage the equipment also if it is severe problem. Due to this, three-phase induction motors will definitely be affected, because there will be lagging of the current and the voltage in case of inductive loads. And irrespective of the type of the industry, the voltage unbalance will affect. For example, the continuous processing industries like cement, textiles, etc. Will use heavy the large number of induction motors, where definitely there will be a problem with the voltage unbalance. IT industries, there could be the problem with the data losses and the functioning of the CPUs. And safety and the security industries like hospitals will also suffer from this, because there will be the ventilators that will be working. There will be the huge systems, ICUs, which are dependent on the electrical systems. And limitations of the distribution systems. Further to it, there will be limitations to all type of systems. So it is equally important to understand what are the limitations of the distribution systems. While designing, this is one of the major factor that any engineer should understand, or any system, any enterprise should understand what is the limitation. Welcome all to the session on limitation of distribution systems, which is totally connected to the reliability and the power quality of the distribution systems. Any enterprise should understand that there is a limitation to the distribution system. While designing, this factor is taken care of. And while designing the distribution system, the limitations are observed and it will be considered, because that is the failure analysis is the one which is going to highlight the product usability and the limitations of a particular product. Similarly, some of the limitations of the distribution systems are thermal limit, economic limit, voltage drops, and several others. Let's discuss one by one individually and one by one thoroughly. Thermal limit is the one, the temperature is of the components, temperature of the working area, and where exactly the system is put into place determines the limiting load current, and temperature determines the limiting load current. Hence, the loading of typical system elements are set by the temperature rather than the mechanical loadings. In the working system, temperature plays a major role. For example, while working on a laptop, if we work continuously on the laptop, if the fan stops working, the temperature increase. So the heat sink of any particular system plays a major role. So the temperature determines. On a larger scale in the distribution system, temperature plays a major role, and the thermal limit definitely puts limitation onto the power quality and also the distribution systems. Economic limit is another one, another criteria which puts the limitation on the distribution system. The heat dissipated in the system components which creates the losses, and it leads to the increase in the cost. So the provision to the heat sink is the major cost that is going to take that is going to be the major part of the cost also. When the cost of the losses equals to the cost of the reducing the losses, it is said to be in the economic level of loading. So it matters a lot when the economic limit matters a lot in the designing of the distribution system. Voltage drop is another one which is going to give a limitation to the distribution system. So voltage drop, when we consider the thermal limit and the economic limits, which are directly related to the voltage drops, and the voltage drop, the magnitude of the load, voltage drop depends on the magnitude of the load also. So while designing the system components, the consideration of the voltage drops becomes another consideration. So the fourth one is the over voltages. Over voltages is nothing but, apart from the voltage drops, the components must be capable of withstanding the voltage surges that is originated from within the system or by external sources. Voltage flickering and then the dips is also going to cause a major limitation on the distribution systems. The magnitude and then the frequent fluctuation in the system in the voltage can result in the disturbances in the performances of the devices that is connected. So the voltage flicker and the dips is also going to set limitations on the system. And the harmonic interference, this can happen due to the arc furnaces and the high switching devices, that is high switching devices which is present in the customer premises or in the distribution channels or with the distribution. So this need to be isolated from the general appliances, and the generation of subharmonic component frequencies may cause the flickering in the light loads, and that needs to be arrested. So with this we will conclude the reliability of the power quality and the distribution system, the limitations of the distribution systems, reliability and quality of the distribution systems from the module 5, distribution systems. So the complete module 5 discussed about the different type of the distribution systems, DC and the AC, one of the major factor of the reliability factor, and the quality of the distribution systems, and then how to assess the quality of the power systems, and what are the limitations that are stood by the distribution systems, and the care that is to be taken care of to keep up the customer promises. With this we come to the end of this module, and with this we have concluded the discussion on the reliability of the system and the distribution systems overall. So we understood about the cables, we understood about the underground cables, we discussed about the distribution limitations.